Hey guys, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at lesson 1 from chapter 4, which is talking about graphical solutions of quadratic equations. So a quadratic equation is an equation in which one of the terms is squared, so it has an exponent of 2, and no other term is raised to a higher power. So here is our general form of a quadratic equation. So here we have ax squared, so we have that squared term, plus bx plus c. And that's all equal to 0, where a cannot equal 0, or else it'd be canceling out that x squared term, and it would no longer be a quadratic equation. So this should look very similar to something that we did in chapter 3. We were looking at the standard form of a quadratic function. So the only difference here really is that we have our ax squared plus bx plus c is equal to 0, where in the previous chapter, it might not have had an equal sign, or it was equal to y or f of x. So with that said, it's going to be very similar methods of solving and graphing that we did in chapter 3. So this here is really just an extension of chapter 3. So when we're trying to solve a quadratic equation, what we're looking for are the roots of the equation, or what we also call the zeros. There are many ways to find the roots, and we're going to look at the first method in this video, which is talking about graphing. So when graphing, the roots correspond to the points where the graph intersects the x-axis. So essentially what we're really looking for is the x-intercepts. So when you graph, where your graph intersects the x-axis, or maybe it doesn't, but that'll depend on the number of solutions. So in our first little example that we have right here, this one here, it does not ever intersect this x-axis. So this would have no real zeros or no real roots, or just 0 solutions. If your vertex is at your x-axis, then you're going to have one real x-intercept, so this will have one solution. And if your vertex is below your x-axis and opening upwards, here you notice that it intersects twice, so this is going to have 2 solutions. This will be the same sort of idea if, say, your graph were to be opening downward. Say, for example, maybe your graph was down here. Well, here our vertex is below the x-axis and it's open downward, so it's never actually going to curl back up and go through that x-axis, so that one would have 0 solutions. And same sort of idea with 1 solution and 2 solutions. So your first step here is we need to graph it in order to determine the number of solutions. So now what we're going to do is we're going to go and do example number 1 from lesson 4.1. So here we're going to determine the roots of the equation by graphing the corresponding function. Then we can verify our answers. So in this equation here we have x squared minus 6x is equal to negative 9. And so as we were talking about, our first step here is to graph. And before we can graph, what you notice is that this equation here is not in standard form. So what we have to do is all your numbers and variables have to be on one side of the equation. So let's move this negative 9 to the other side. So we want to make this a 0, so you want to do that opposite operation. So if this is negative 9, you want to add 9. And make sure what you do to one side, you do to the other. So we have x squared minus 6x plus 9 is equal to 0. Now our equation is in standard form, meaning we can go ahead and start doing the calculations in order to graph. So if you guys remember from chapter 3, whenever we're trying to graph something that's in standard form, we always want to start by finding that vertex, because that goes in the middle of our table of values, and then we're going to do a couple values above, a couple values below. So let's start by finding the vertex, and you're going to find it exactly the same way that you did in chapter 3. So you're going to use the equation x is equal to b divided by negative 2a. So we're looking at our standard form. This x squared term has an a value, the x term has the b value, and your term without the variable or that constant is the c value. So b here is negative 6. So we'll write x is equal to negative 6 divided by, so it's negative 2 times a, which if there's no number there, you're going to assume it's just 1. So we have negative 6 over negative 2 times 1 is negative 2. And then we can simplify that division there. And negative 6 divided by negative 2 is positive 3. So that means our vertex is at an x value of 3. And then what we can do is, then we can start moving on to our table of values to find out where your y values for that intercept, or for your vertexes, sorry, and for those other values. So we're going to start off by doing our table of values in order to graph. And as I said earlier, make sure that your vertex goes in the middle of your graph, and then you'll choose a couple values above, a couple values below. So maybe you want to go with 1 and 2, and then your other values should have the same distance apart, just that we can see those mirrored points. Then you probably want to go with 4 and 5. So what we're going to do is we're going to plug each of these x values into your equation, and then we're going to solve to find our y value. So our equation here is, so it's x squared, so we're going to put 1 in for x, so we have 1 squared, minus 6 times x, so minus 6 times 1, plus 9. So we can go ahead and simplify this. So 1 squared is just 1, negative 6 times 1 is just negative 6, and positive 9 is just plus 9. Then we can do the adding and subtracting there. So 1 minus 6 is negative 5, plus 9 would give you a value of positive 4. Now we're going to do the same with our x value of 2. So we have x squared, so we're going to have 2 squared, minus 6 times x, which is 2, plus 9. Starting with our exponents here, we have 2 squared is 4, negative 6 times 2 is negative 12, and plus 9. Then you can do your adding and subtracting. So we have 4 minus 12, which is negative 8, plus 9 is positive 1. So this here is our y value for x is equal to 2. Then just keep repeating this process for the rest of your values. So you have 3 squared minus 6 times 3 plus 9. So 3 squared here is 9. Negative 6 times 3 is negative 18, and plus 9. So 9 minus 18 is negative 9, plus 9 would give you a value of 0. So here our vertex is at 3 and 0. So just remember, from here on out, the rest of those points should mirror after that vertex. So our next value here, 4, should give us positive 1 if we did our work right. Same with 5. 5 should give us that mirrored value, which is going to be 4. But make sure you do the math to make sure you didn't make any errors before. So we'll put 4 in for x, so we have 4 squared minus 6 times 4 plus 9. 4 squared is 16. Negative 6, times 4 is negative 24, and then plus 9. So 16 minus 24 is negative 8, plus 9 is positive 1. And so here we're starting to notice we have those two mirrored points. So far, our work is correct. For the most part anyways. All right. Then we have 5. So put in 5 squared minus 6 times 5 plus 9. 5 squared is 25. Negative 6 times 5 is negative 30, and positive 9, or plus 9. So here you have 25 minus 30 is negative 5, plus 9 is positive 4. So here we've got those mirrored values, so that at least tells you you're on the right track. And now that we have these, now that we have all the values to graph, now we can actually go up to that graph and plug in those values. So our first step here to graph is that we need to label our x-axis and we need to label that y-axis. So in order to figure out your spacing, you really have to look at, well, what kind of values are you given here? So looking at your x-axis, your highest value here is going to be positive 5. So if we're going up to our graph here, you can play around with it, but you could try maybe every 1 line or 2 lines is just 1. So let's try 1 line. If we went 1, 2, 3, 4, 1, 2, 3, 4, 5 here, that wouldn't be using very much of your graph. So you might want to go maybe by every 2 lines. So you go 1, 2, 3, 4, 5, and that would get you really close to the end of that graph. So you're using at least a bigger chunk of that graph. So your that parabola or the quadratic equation is not going to be very squished in. So you kind of have a better idea of what's going on. So let's label that. So we're going to go every 2 lines is going to be 1 value. I'll label just a couple in the negative direction. Then we need to look at our y values. So look at what is your highest y value. So in this case here, our highest y value here is 4. So we will probably use the same spacing. So let's try every 2 lines as 1. So we have 1, 2, 3, 4, and 5. So that one there actually uses a good chunk of that graph, so that's pretty good. And I'll label just a few in the negative direction. All right, so from here, now we have our x and y axis labeled. Now we can go ahead and start to graph. So our first value here is x is equal to 1, y is equal to 4. So x is equal to 1, y is equal to 4. Then our next value there is 2 and 1. So x is equal to 2, y is equal to 1. Then our x value here is 3 and 0. That's our vertex. Then our next value is 4 and 1. And then that last y value that we had there was 5 and 4. Then what we can do is, we know that with parabolas, they have a nice smooth U-shaped curve. So when we're connecting our dots, just make sure you follow through and have a really nice smooth curve over that vertex. And hopefully you don't have as shaky of a hand as I do here. And once again, don't forget, you need to have arrows on the end of your graphs because we only chose numbers 1 to 5. But we could really keep going with those numbers, so you need to show that that graph could go on and on forever, so make sure you use those arrows. So this last part of the question, here we need to find out what our root is, and so our root is where it crosses that x-axis. So where is our x-intercept, and that right there is x is equal to 3. And one thing that's really important though is that when we're trying to find our roots or our solutions, you're not going to give me that y value. In our equation, we didn't have any y values, so make sure do not include that y value. So you only want that x value. So here you'll say that x is equal to 3. And then to verify it, you're just going to plug it into your equation and show that your left side is equal to your right side. So here we have, so it was x squared, so we have 3 squared minus 6x, so minus 6 times 3. And then we had equals negative 9. So one thing that's really important is make sure you use the original equation. So then let's go ahead and solve this left-hand side. So we have 3 squared, which is 9, and negative 6 times 3 is negative 18. And make sure you bring down everything else. So you still have to write that equal sign and the negative 9. Then we can do our subtraction. So we have 9 minus 18. So we show that negative 9 is equal to negative 9. And that's how you verify it. So show that left side is equal to right side.